what we should expect from physics is very broadly said. There are many different branches of physics, and in each of the branches there are new developments. But if we just focus down on what we're talking about here, namely on how materials change our lives, they have already changed our lives a lot in the past years. So just think of mobile phones. Physicists are behind the way that mobile phones work, and like that, there are new developments which go in the direction of new materials for the energy transition. We need batteries, we need hydrogen storage materials for running our cars on hydrogen instead of on fossil fuels. We need batteries to use the non-constant sources of energy like windmills or solar cells. Here in Spain you have the fortune that solar cells work better, but in the north of Europe where I am, you can't have a lot of energy every day. So we need to store it. But you can also think of other uses like which influence our life through sensors. What we can, for example, right now we are learning where there is water in the ground. If you asked 5 years ago, where is water in the ground? Nobody could give you an answer. We are getting there now because now we have the sensors that can see where it is. So physics contributes really to our quality of life, and you can also think of healthcare, of new devices for treatment, of new materials for drug delivery. There are lots of versions of new developments that are very fundamental to our quality of life. We have, in the last decennia, we have lived a development where we went from bulk materials, macroscopic materials with certain properties, to nanomaterials. And right now we are going into flatland. We are thinking about 2D materials, which have different properties and which have often new possibilities because we can use them the same way as children use Lego. We can combine them, and we can combine them with pillars in between. And in this way, we can make very, very interesting new materials for energy consumption, for energy production and storage. We can make new materials for healthcare, for drug delivery, and so on. There is really completely new possibilities that we did not think about before graphene. So graphene, in a certain way, has shaken up our conception about materials. Because seeing with graphene that there is this new material that has these very special properties, we have thought also that not always we need such a perfect material, but also carbons, porous carbon materials, very thin sheets of carbon arranged in different ways, that we can get, for example, in a circular economy from waste. They can also have certain properties which are very useful for taking out things from the drinking water, like pesticides or herbicides which are there, or metal ions that we don't want. We don't need to have perfect graphene. We can take other porous materials and use them. And like that, the 2D material graphene has opened our mind to consider new materials in our research. When I started my career, the percentage of women in physics was much lower than what it is now, but we still have a long way to go. And one of the problems is that people erroneously think that if they treat everybody equal, that solves the situation. But this is not true. What you have to do is you have to become more inclusive, which means that you have to think for every group of people that you want to include in the community, whether this is first generation students, whether this is women. We have lots of sources for talent. You have to think no longer I treat everybody equal, but you have to think this category, what does this category need to thrive? And then you put into place special actions for each of these groups that you want to include, and your community becomes more diverse. And that's something that is really a concept of what democracy is, which has to change among the scientists as well, because there are lots of my colleagues who are firmly convinced that if they treat everybody equal, everything will be fine. But this is not true. So that's the way we have to go. That is not only a question of physics, because what we need in order to have an energy transition is a change in our behavior, which is something that has to go together with the technological developments. Technology cannot save humanity if humanity does not change its habits. So the idea of going somewhere for a weekend just because there the beer is cheaper is something we really have to forget about. And everybody has to think how he or she can contribute to changing our energy consumption, because we have to reduce it. There is no other way. And everybody can do a tiny little bit, and all together, all these tiny little bits will make a change. And so a lot of people nowadays think that, but I can just do a little thing. But it is the little thing which makes the difference. So we have to abandon certain habits that we have. And instead of traveling many times per year, as now many people do, well, we have to think that maybe there are wonderful places around here that you can reach by bike, where you don't need to consume a lot of energy. So it is these changes: no more one-way plastic, no more expensive travel, etc., etc. And we can do a lot. Isolating our houses. There are lots of ways in which we can change.